Now that we remember a little bit about these inverse trig functions, let's take a look at their derivatives. So we have the derivative of arc sine as 1 over the square root of 1 minus x squared. The derivative of arc cosine is negative 1 over the square root of 1 minus x squared. Derivative of arc tangent is 1 over 1 plus x squared. The derivative of arc cotangent is negative 1 over 1 plus x squared. The derivative of arc secant is 1 over the absolute value of x times the square root of x squared minus 1, and arc cosecant of x is negative 1 over the absolute value of x, square root of x squared minus 1. Okay, so you can just look this up in the textbooks and see what these are. But I want to point out a few things for these, right? The first off is that these two look very similar. These two look very similar, and these two look very similar. The only difference is a negative sign between these. So a negative sign is going to appear when you have the c's. So when you have this cosine, the cotangent, and the cosecant. So if you want to remember that, think about c's. Those are bad. We don't like c's. Those are negative. So C is like the gray, not like the bodies of water. Those are perfectly fine. We like oceans and seas and that. But the grade C we don't like. So c's are bad. Those can be our negatives. And just remember how these two are, how they're all paired up with each other. It's not sine gets paired up with secant in this case. It's the fact that sine and cosine, and we have tangent, cotangent, secant, cosecant. Those get paired together. But this is just the basic derivative. Remember, we also have the chain rule that we want to apply where necessary. So if we take a look at this example of arctangent of x squared plus 4. The derivative of arctan of whatever, this is going to be a composition of functions. The arctangent, the outside function, is 1 over 1 plus x squared. So I do this, 1 over 1 plus x squared plus 4 squared. So remember, this is the outer function that I'm taking the derivative of. The outer function is arctangent. That is going to be 1 over 1 plus that something squared. But remember, we do the chain rule. Now I take the derivative of the inside of x squared plus 4. So I multiply this by 2x. So there we go. The derivative of arctangent of x squared plus 4. Here, now if I take arc cosine of 3x divided by x, when I take the derivative, well, first off, I have to use the quotient rule. So I take the bottom. Now I take the derivative of arc cosine of 3x. So I look over here to see the derivative of arc cosine. So that's going to be negative 1 over the square root of 1 minus 9x squared. So I put in the 3x, and that's being squared. But chain rule still needs to apply. So now I multiply this by the derivative of 3x, which is 3. So I plug in the 3x down there, and I take the derivative of it. So that's the first times the derivative of the second, or the bottom times the derivative of the top minus the top times the derivative of the bottom. So I am left with an arc cosine of 3x. All of this is divided by the bottom squared. So you use the quotient rule and making sure you use the chain rule appropriately. Here, our x times our cosecant of the square root of x. Again, we need to use the first rule is the product rule, then we use this. So I'm going to take the first times the derivative of our cosecant of x, or the square root of x. So now I take this. So I have a negative 1 over the absolute value of the square root of x times the square root of the square root of x quantity squared minus 1. So that's what happens when I take the derivative of our cosecant. I have this, but I plug in the inside, the square root of x. That goes in everywhere there's an x. But I multiply this by the derivative of the inside. So I multiply this by the square root of x. I get a 1/2 times x to the negative 1/2. So that is my first. The derivative of the second is this. Then to finish off the product rule, I take plus the second, which is arc cosecant of the square root of x times 1. Now, if If you'd like to understand why are these the derivatives, let me know. I'd be happy to make a video explaining the math behind this. But I figured at this point, your brain is probably becoming mush at this point in the semester, so I'm not going to make more videos that you don't really need to watch. So that's one thing. If you want to see why is that the case, let me know. But the other really important fact that I want you to take away from this is that the derivative of these inverse trig functions have nothing to do with sines, cosine, tangents, any of that. So the derivative of arc sine has nothing to do with, say, arc cosine. It's not the same properties as the relationship between sines and cosines. Here, we lose pretty much all of the trig that you normally know and love, and we're now just with x's, square roots, things being squared, and so on and so forth. So when we look at integrals, we'll want to be very, very careful.